Hello everyone, a very warm welcome to this video. In this video, we are going to talk about three major topics. Cluster security, cluster monitoring, and cluster maintenance. So let's first talk about cluster security. In this section, we'll talk about default security options, and then we'll talk about Kerberos. Security is extremely important. There is no two ways about it. One of the most important aspect of computer industry or software industry is security. Making sure that right people have access to right data and your data does not get into malicious hands. Now let's talk about security from Hadoop's perspective. Do we really need to worry about Hadoop from external hackers? Well, not really. Hadoop is not a system that is available on the web for people to access. It is typically inside. It's something that complements your data warehouse. So technically, you don't have to worry about hackers who are outside or malicious people who are outside your organization, because Hadoop will be well within your firewall, just like your data warehouse. So if your firewall is good enough, you don't have to worry about your data warehouse getting hacked because it's inside the firewall. Similarly, the first level of worrying that we want to be sure that Hadoop is not accessed from outside, it's something the firewall will take care. And you will typically have virtual private networks in your organization which will let you access Hadoop. So let's just say that securing Hadoop from the external world is not really a concern, because the firewall should take care of that. The next thing we are going to talk about is how do you secure Hadoop within the organization? How do you secure the Hadoop within the organization? So within organization, well, Hadoop inherits, or Hadoop file system inherits the Unix file system permissions. So same like read, write, and execute. Execute does not really apply to Hadoop because nothing could be executed. So that's the default security that HDFS provides. You have read, write access, so you can kind of control who gets to see what or who gets to read what. But sometimes this will not be enough for us. Sometimes this will not be enough for us. So what we really need is a more tighter control, and what we really want is a very strict authentication and authorization. Now, to tackle that, we will be using something called as Kerberos. Kerberos is not part of Hadoop, neither is it created by Hadoop. Kerberos has a lot of implementations. MIT has an implementation of Kerberos, and all we need to do is implement Kerberos with our Hadoop. So let's first see how Kerberos works, and then we will see how would you go about doing this in Hadoop. Now, it will technically not be possible to have Kerberos being done in the lab, because Kerberos is very version specific to Hadoop, and every version has immense amount of changes when it comes to implementing Kerberos. So the best idea would be figure out what's your version of Hadoop, and based on that follow the documentation. So even a minor change in the version would have certain changes for Kerberos which you'll have to take care of. And in a lot of ways, Kerberos is a separate course in itself. So what we are going to do here is we are just going to talk about how Kerberos is going to work. And if you want to set up Kerberos in your production, you'll have to find out what's accurate version of your Hadoop, and based on that follow the exact same documentation. Failing to do so would basically attract or have lot of vague permission denied errors. So let's understand how does Kerberos really work. Kerberos basically has or involves three different actors or components. So this is the one of the component is Hadoop cluster. So everybody would want to access this cluster for accessing a file in HDFS or running a MapReduce or a Spark program. So this is end user, that's yourself or myself, who wants to talk to this Hadoop cluster for a service. And then you have a third component that's called as KDC, which is Kerberos Key Distribution Center. This is the central component that's basically used to secure your cluster. So when an end user wants to access a service on Hadoop, it first goes to KDC and it basically requests that I would like to perform this particular operation. Now, based on the permissions that you have typically in an LDAP or Active Directory, KDC will verify that and give you something called as a ticket or a token. So it gives you a ticket or a token. And KDC stores that ticket or token with itself, associating your username or other details. Once you get the ticket or token, you actually access Hadoop cluster for a service, and Hadoop cluster would then talk to KDC, verifying if this particular user is a legitimate user and does it have the permission that's required. If the KDC verifies it to be valid, then your request will be served by the Hadoop cluster. This is how your Kerberos would work. So at the end user level, you would talk to KDC. KDC, based on Active Directory or LDAP and its own permissions, would let you know whether you are legitimate or not, or whether you are authorized to do something or not. If you are authorized, what you get is a token. You push that token to the cluster, you will not be doing anything. It's part of the software. And cluster would then talk to KDC and verify if this user is valid or not. If it's valid, then you get to use the service. This is how Kerberos secures your cluster. So on a high level, the steps that you are supposed to follow in implementing Kerberos is: step 1, you should have a working Hadoop cluster. Step 2, we want to have a working KDC. KDC is Kerberos Key Distribution Center. Typically use MIT. Step 3, install Kerberos agent or client libraries on all the nodes in the cluster. And step 4, it's ready. So what you need is a working Hadoop cluster. You need a KDC, and on this particular slaves, you just need Kerberos agent libraries and you are good to go. Every request would then point to the cluster, and cluster would verify if you are good or not. And based on that, you would have your stuff working. Now, Kerberos can be integrated with Active Directory or LDAP, and it can take care of all the permissions. Along with that, Kerberos could be integrated in such a way that every employee in your company already has a Kerberos account or account on Hadoop, by setting up something called as one-way trust, where any user that's on LDAP would be trusted by Kerberos Key Distribution Center and would be given permissions based on the permissions in the LDAP. That is how you secure your Hadoop cluster. So this was all about security. Let's quickly summarize it. So what we've seen is we've seen the default security options and we've seen Kerberos. In Kerberos, the silent features are what we need is we need a working Hadoop cluster. We need a KDC, Kerberos client libraries installed on all slaves and master, and Kerberos can be integrated with existing LDAP. So this was all about cluster security. And to basically implement cluster security, make sure that you are having the accurate documentation for the version that you have. Kerberos security could be easily implemented using Cloudera Manager. That could be done. So now let's talk about cluster monitoring. In cluster monitoring section, what we are going to talk about is what is monitoring, what to monitor, monitoring without Cloudera Manager, and monitoring with Cloudera Manager. And then we'll talk about few troubleshooting techniques. So let's start with what exactly is monitoring. Monitoring is an act of making sure that the system is up and running. Monitoring is an act which basically ensures that the system is up and running and the end user is happy. Or in other words, monitoring is an act where we ensure that the system is up and running optimally. Monitoring is very important because without monitoring, there is no way to really figure out what's gone wrong, and there is no way to ensure that systems will be up and running all the time. And it will be very tough for us to diagnose something. Now, when we set up a Hadoop cluster, what are the things that we should be monitoring? What are the things we should be monitoring? What we should be monitoring is all processes like resource manager, name node, data node, node manager up and running. To monitor heap space, monitor CPU utilization, monitor if HA is working as expected, monitoring disk space on each machine, monitoring HDFS space. We'll also have to monitor if name node is up and running, monitoring log file growth. These are some of the things that we need to monitor when it comes to our Hadoop cluster. And what we really need is certain tools that can help us do that. So there are two ways in which we can monitor our Hadoop cluster. So let's talk about both of them. So the first one is fairly easier one, which is Cloudera Manager. So there'll be, in this course, we are going to talk about how to monitor your cluster with Cloudera Manager. So Cloudera Manager has inbuilt monitoring. You can monitor performance on a node level, monitor performance on a service level, get warnings, get alerts, also get the best or recommended values for a certain config. All this is part of Cloudera Manager. So once you install Cloudera Manager, what you're going to get is you will be getting the facilities that are inbuilt monitoring. You can monitor performance on a node level, monitor performance on a service level. You can get warnings, get alerts. Also, you get the best recommended values or the most recommended values based on your cluster. In the future videos, what you're going to see is there is a session on Cloudera Manager where we are setting up Cloudera Manager. And in the lab, what you're going to see is that if there are some things going wrong, Cloudera Manager would throw warnings and we would basically be fixing those warnings. Cloudera Manager has, for each and every service, it has more than 150 charts, which will actually show us what's really happening with our cluster, So Cloudera Manager, if you have Cloudera Manager, technically you don't need any other monitoring solution. And as of today, anybody who deploys Cloudera Manager, 95% of the deployments are using, if you use Cloudera Hadoop, 95% of deployments will be with Cloudera Manager. So in case you are having Hadoop with Cloudera Manager, you don't have to worry about monitoring. But if let's say we don't have it, which is going to be a very rare case, because if enterprises, there is no use case where enterprises use Hadoop from Cloudera, but they don't use Cloudera Manager because the manager gives us the entire solution. But let's say if we don't have it, what are our options? Hadoop provides a framework called as Metrics 2. Now with Metrics 2, Hadoop exposes the metrics information for the external world. So in a nutshell, the way it would look is you would have Hadoop cluster with a master and slaves, and each machine exposes its metrics. Each machine exposes its metrics because Hadoop has a metrics framework. Now, once these metrics are there, these metrics can be consumed by two ways. So this metrics can be consumed by something called as metrics sync or message beans. So this metrics that Hadoop is exposing can be consumed in two ways if you're not using Cloudera Manager. One is metric sync, another is message beans. Now, for example, for monitoring tools like Ganglia, you have something called as a Ganglia metric sync. A Ganglia metric sync would basically expose the information, and a Ganglia monitoring tool can directly catch that. Tool can directly get that and expose it on the UI. So like this, there are monitoring tools, majorly it's Ganglia, which will directly get update from a sync. So metrics, Hadoop metrics framework is exposing a metrics, sync is capturing that and putting it on the monitoring tool. The second way is mbeans, which is message beans. Any monitoring tool with JMX support. JMX is Java Management Extensions Support, can consume this message beans and have a UI which will show the monitoring information. So each and every machine, be it master or slave, would expose metrics information, and these metrics information could be consumed in two different ways: metric sync and message beans. So when you have metrics sync, you have tools like Ganglia, which have a customized metric sync called as, let's say, Ganglia metric sync, and Ganglia metric sync will simply get the information and update it on the UI, and what you see is a beautiful UI. Now this can also be integrated with an event management system like Nagios, where you can get alerts. So if a certain value or certain thing happens, you would get alert in terms of emails or other notifications. This is how monitoring could be set up for non-Cloudera management systems. For our lab, we are going to concentrate on monitoring that is available in Cloudera Manager because that's extensive. For each service, we typically get 150 charts. And as of now, there is no tool in the market that could give us that comprehensive monitoring that Cloudera Manager provides. So this is all about monitoring your Hadoop cluster. So far, a quick recap, what we've seen is we've seen how security can be implemented in a Hadoop cluster. And second, we've seen how monitoring works. When it comes to monitoring, Cloudera Manager is the best solution. If not, you have Ganglia, Sync or MBeans, which will basically expose information and can be displayed on a monitoring tool. The next thing that we are going to speak about is called as quick troubleshooting tips. How do you troubleshoot if there is a problem? Well, to a surprise, around 50% of support tickets for Mapper, Hortonworks, Cloudera and Apache community are because of misconfiguration. So when you say misconfiguration, your heap sizes, sometimes if you're not using a customized or product, you would have spelling mistakes a lot of times. So just to give you a quick example, you have given 4 GB of, let's say, Java ops or Java RAM to Java for JVM. You've given 4 GB, that's kind of the maximum, but still your developers complain that they are getting heap size error. So a classical case, you've given 4 GB JVM, or to a JVM you've given RAM of 4 GB, and still your developers complain that they are getting heap size errors. Now let's understand why that's happening. When you give 4 GB of RAM to a JVM for a mapper or reducer, if you don't configure the heap space, unfortunately 200 MB is the default heap space. 200 MB is the default heap space. Now the recommendation is 3 GB. That's 75% of the JVM RAM given to the JVM for mapper or reducer. But what we have done is, if we leave it to default, it's 200 MB. This is one of the most common, or this could be called as the poster boy of misconfiguration. One of the most common misconfiguration administrators do is they give 4 GB to their mapper and reducer and they forget about it. Suddenly the developers start getting errors in Java heap space and the administrators are really struggling. This is something that you will see, like 75% of issues in production due to heap space are because of this. Because a lot of times administrators forget the fact that if you give 4 GB of RAM to a JVM, the heap space by default is 200 MB. And you will have to set that up individually to make it typically 3 GB or 75% of the entire RAM. This is one of the most common case that you will have. Few other another poster boy of the whole thing is this is something very common that administrators would sometimes make a mistake. Well, Hadoop has a recycle bin kind of a concept where if you delete something, you can recover it. By default, the trash is disabled, and recommendation is have it 24 hours. Now the point is, this is another poster boy of misconfiguration where you see that the trash by default is disabled, and a lot of times customers complain that we've lost our data, we should have been recovering it from the trash folder. Well, the point is, by default trash is disabled, and as an administrator you should enable this for yourself. So these are some of the most common issues that you will basically find in Hadoop. So be sure that you understand, you look at the best practices that Cloudera has on its website. So there'll be good 200 odd best practices which cannot be covered in a single video. But you could visualize or you could visit the Cloudera's documentation and look for these quick tips as to what are the most common mistakes people do, how to tune your cluster for the best performance. But these two are, let's just say, the poster boys of misconfiguration when it comes to Hadoop. So this was about misconfiguration. What are other issues as an administrator you can find? Another most common issues you will find is disk space. If you're not careful, suddenly you will be running out of disk space on one fine day. So be sure that you continuously check how much or monitor how much disk space you have remaining on the slave nodes. A good idea would be every time you cross on a disk 75% of space limit, get an alert for yourself so that you are aware that in case your cluster is running out of space, you will quickly provision new disks and have them. This is another most common problem when it comes to your Hadoop cluster. Third is, please monitor log file growth, because log files could continue growing and it will be a big source of pain for you. So these are some of the troubleshooting tips that we have. First, 50% of your problems will be because of misconfiguration, and misconfiguration can be anywhere. So make sure that you read documentation for recommended values for each one of them. Make sure you monitor your disk space and make sure that you continuously monitor your log file growth. So these are some of the tips that you have. Along with that, when we do the video for cluster walkthrough, you would see how to walk through a cluster and how to see your job, how it's performing, and so on and so forth. We'll be also discussing a concept called as counters in the code walkthrough videos. Let's talk about the final quick tricks for debugging an issue. So let's quickly put some perspective to it. Now, whenever you have an issue, ask yourself, is this issue across cluster? If it is across cluster, then probably most likely it's a config issue of resource manager. Let's say while you are running a job. If it's failing on certain machines, then most likely it is an issue with the node manager. If it is cluster wide, check resource manager logs and fix the issue. If it is node manager wide or it's on certain node managers, check the node manager issue. Now the third permutation is it that your job, so is it that both of them are fine, but if your job is failing, and if your job is failing, let's just put it here, if it's an issue with only the job, so all good, but job failing, then mostly it's a issue with your code, your heap space. Code and heap space are the most common issues that you will have. So these are some approaches that you will have to deploy. That is this issue with the cluster, or is it only with a certain machines, or is everything good but it's just the code and the heap size that's an issue. So this was all about monitoring. So what we've seen in this course so far is cluster security, where we saw what are the default security options and how Kerberos could be implemented. Then we went to cluster monitoring. We understood what is monitoring, what to monitor, monitoring with Cloudera Manager, monitoring without Cloudera Manager, and we've seen quick troubleshooting techniques and tips. More on troubleshooting and viewing the cluster components would be done in one of the video called Cluster Walkthrough. And now we move our focus to the third topic of this video, and that's called as cluster maintenance. In this section, we are going to talk about cluster maintenance. So when we talk of cluster maintenance, we are going to talk about dealing with file system corruption, dealing with balancer, dist CP, adding nodes, removing nodes, and we'll also talk about rack awareness. We'll talk about rack awareness. So these are the topics that we are going to talk about when it comes to an important utility called as DFS admin. So these are some of the topics that we are going to discuss in the next section, which is cluster maintenance. So let's first start with file system corruption. Well, there is no way to repair a file system corruption in Hadoop, but there is a command that tells you if the file system is healthy or not. And the command is Hadoop fsck. Fsck command will tell you if the file system is healthy or not healthy. Linux fsck tends to fix issues for you, but Hadoop fsck will not fix issues for you. So the only two options if your file system is corrupt, the first one is delete. That means delete corrupted files. And the second option is called as move. That means move corrupted files to a lost and found folder. These are the two options that you have if there is a corruption, and fsck will just tell you if there is a corruption or there is no corruption in your file system. But there is no other way to fix this for you, can be delete or move. So Hadoop fsck is the command to be used for detecting that. So there is no way to repair as such. The next thing we are going to talk about is called as dist CP. So we'll first talk about DFS admin and then we'll talk of dist CP. Now Hadoop has an interesting command called as DFS admin. This is a set of admin commands. So let's look at a couple of commands from this DFS admin. So if we run a command sudo hadoop hdfs hadoop dfs admin report, this shows us list of data nodes in the cluster and on per data node basis the amount of space given to HDFS. The next command in this would be sudo -hdfs hadoop dfs admin save namespace. The save namespace command will basically force the secondary name node to merge data from name node or perform checkpointing. Checkpointing is discussed in the high availability video. So the first thing we saw is when we are maintaining a cluster, if we want to see if the file system is healthy or corrupt, we would look for a command called as Hadoop fsck. If we want to do some administration activities, one command that has everything is called as dfsadmin. Along with dfsadmin, there are multiple options. In this example, we've seen couple of options: report and save namespace. Like this, there'll be another 5-7 options which the documentation would talk about. There is another option called as safe mode enter, safe mode leave. So those kind of options are there for you to explore. So what we've seen so far is corruption, and we've seen the dfsadmin command. Let's look at the third command or the third utility, which is called as distcp. What exactly is distcp? So if we have a 100 node cluster in a data center in New Jersey, what if the entire data center goes down? What if the entire data center goes down? How do you really tackle that? Well, in that case, you will actually need to have another data center. So if you really see in enterprises, you have a main site and you have another site which can also be called as disaster recovery. And there is a command which can keep both the clusters in sync, and that is called as distcp. So distcp is a command that will any day keep both the clusters in sync. As soon as a file gets written here, an administrator can, let's say, run a cron job every 15 minutes, and the files would also be kept in sync here. Now the way distcp works is it looks at the checksum of all the files here, and based on that, the files that have checksum which is not there here, only those files will get copied. Only those files will get copied. So distcp is nothing but distributed copy. This is the command that will help you keep two clusters in sync if you would want to. Now a general practice is when your data is ingested, you will run the jobs here, and on the other side you will simply put the data, because if this cluster goes down, we can still run the jobs and recreate the data here. So the idea is jobs would be run on any one cluster. So there are three important points pertaining to distcp. First, can copy data within cluster, can copy data among clusters, and using checksum can figure out only new data and push that to the second cluster. And the fourth point is normally jobs are only run on one cluster, and if that cluster goes down, the output data can be again recreated by running the same jobs. So that was distcp in a nutshell. That was distcp in a nutshell. So we've understood how to tackle file system corruption. We've understood how to go about dist CP, which is keeping both the clusters in sync for disaster recovery. Dist CP can also copy the data among the cluster. DFS admin is a command that is admin utilities. The next topic that we are going to talk about is balancer. So let's understand what exactly is balancer. As of today, let's say we have a cluster and we have 5 slaves. So as of today, we have a cluster and we have 5 slaves. And let's say as of today, the data we have is 80 GB. Totally, it's 80 GB. Technically, what that means is each slave has 16 GB of data. Each slave has 16 GB of data. Now, what if we add another 5 slaves? What if we have another 5 slaves? The question is, will the data automatically move? The answer is no. The data will not automatically move. So now again, in this cluster, totally as of now we have 10 slaves. Data is 80 GB. Slave 1 to 5 has 16 GB and 6 to 10 has 0 GB. Now we add another 80 GB. So what really happens? What really happens? By default, machine 1 to 5 would end up having 24 GB and 6 to 10 would end up having 8 GB. So the point is, by default, HDFS does not give preference or more data to the new slaves. That's not going to be the case. By default, HDFS does not give preference or more data to new slaves. This is by design, because if all the new data was given to new machines, and if you run a MapReduce program for the new data, only 5 machines in the blue would end up processing and remaining 5 would not be utilized. So if you wish to balance it out, you can run a balancer utility. So what exactly is a balancer utility? Balancer utility will take this particular scenario, and what it looks at is that totally there are 10 machines and total data is 160. So balancer will ensure that none of the machines have 16 plus 1.6 or 16 minus 1.6. The threshold is 10% by default. That means no machine can have more than 17.6 and no machine will have less than 14.4. GB of data. So the balancer will balance it out in such a way that if 10% is the default, 10% is the default threshold, at the end of it, it will ensure that none of the machine have more than 17.6 and none of them have 14.4. So balancer works in such a way that if threshold is 10%, that is default, no one will have 16 plus 10% that is 17.6, or no one will have less than 16 minus 1.6, that is 14.4. So balancer balances out the entire data for you, so that ensures a better distribution. So this is balancer. Balancer is a utility that will balance your data across the cluster in such a way that by default, if the threshold is 10%, no one will have mean plus 10% and no one will have mean minus 10%, less than mean minus 10%. That's the idea of having a balancer. Balancer is out here to balance out the storage capacity utilized on the cluster. So that's the balancer utility. So far in the maintenance section, we've seen file system corruption, we've seen balancer, we've seen dist CP, we've seen DFS admin. Now let's quickly talk about how do you add and remove nodes in your cluster, and then we talk about rack awareness. Adding and removing nodes from your cluster, both these activities don't really need a restart of the master. So let's understand this on high level. Now there is a concept called as DFS include and DFS exclude. DFS include is a file that will only let machines in DFS include list act as a data node, and exclude means everybody is allowed except these machines. So DFS include means only these members are allowed, and DFS exclude means these members are not allowed. So when you are adding a new node, you will simply add the IP of the new machine to include file, and we will run a command which is called as refresh nodes for HDFS and yarn, and that will ensure that the new machine is now seen as a data node and a node manager. When it comes to removing a node, exactly opposite process has to be followed. So it will be removing a node, add the IP in the exclude file, refresh nodes, and this will ensure that the machine is now seen as decommissioned. So what we've understood here is commissioning is a process of adding a new node, and decommissioning is a process of removing an existing node. For both these processes, the restart of name node and resource manager is not required. It's not required. So this is a concept of commissioning and decommissioning nodes. Quick check, file system corruption is clear, balancer, dist CP, DFS admin, adding and removing nodes. And the last topic we talk about is rack awareness. Now, name node can be rack aware. What that means is there are ready-made rack awareness scripts available. With rack awareness, name node can place a file, place a block blk001 on say rack 1, and other two replications will certainly be on some other rack, say rack 3. So rack awareness is a concept where you tell name node that put a block on this rack and the remaining two blocks will be on some other rack, so that if a rack goes down, you still don't lose your data. So HDFS provides you that particular protection. So in such a way that if a rack goes down, you still have 2 copies, or if a rack with 2 copies go down, you still have 1 copy, and that will be completely done for you. So that brings us to the end of this important chapter where we saw what is security, what is monitoring, and what is cluster maintenance. Cluster security is all about, there is a base security which is read, write, execute permissions, but that may not be enough. So we can implement something called as Kerberos. With Kerberos, what happens is we can integrate it with LDAP and decide what permissions are given to what user. So in Kerberos, you have 3 actors, the client, the cluster, and a KDC. Client talks to the KDC, gets a token, and based on the token talks to the cluster, and cluster then talks to the KDC and verifies if you have the ticket or not. So that is how Kerberos works. When it comes to monitoring, what we are supposed to monitor is our log file growth, our disk space, if processes are running, if high availability is working. We'll have to always keep an eye on them. To do monitoring, there are 2 major ways. One is Cloudera Manager, which is incredible features and are going to be covered in the lab. And second is non-Cloudera Manager based, where you can have a metric sync like Ganglia or message beans, basically any monitoring tool that supports JMX. When it comes to troubleshooting, we saw that misconfiguration is the most important cause of Hadoop systems failing. The 2 poster boy problems we saw, one was related to heap space, second was related to trash. Along with that, we also saw that how to narrow down a problem. If the problem is cluster wide, go for resource manager. If the problem is node manager wide, go for a node manager log. If node manager and resource manager are working perfectly and you still have a job failing, should be the code or the heap space. So that was security and monitoring. When it comes to maintenance, we saw that what are the problems, what could be a file corruption, and how to verify that using fsc command. We saw balancer, which will balance out your data across the cluster. We saw dist cp, which will basically copy data among the clusters. We saw dfs admin, which basically is set of utilities or commands that are there for administrators. We saw how to add and remove nodes, and we also saw rack awareness. On the parting note, name node is smart enough to have self-healing features where if a node goes down, name node will automatically replicate the data. As an administrator, you don't have to really worry about it. So that brings us to the end of this very important chapter where we covered security, monitoring, and maintenance. Thanks for watching this video.